Hello everybody, welcome back to From Rhythm to Algorithm Part 31, Basis and Range. So we've done a lot of physics, a lot of math, a lot of whatevers. But now we're going to start making these mathematical, logical, and linguistical arguments direct physical arguments. So we've talked a lot about basis and range. Right now there's one basis. The basis of psychology is love. The basis of, again in a practical way, the basis of everything is vibration. And you have light, then you have sound. Sound is the product of objects with mass moving. But at the very beginning, like once, twice, thrice, I think it was like the second episode or third episode, but we said 2 exponent 3 should mean something physically, and now I've realized it's colors. So, alright, we can take vibration and we can make that a direct physical argument. How many ways can you divide light that is colors? How many colors are there? And there are 7. So in a recent episode we've said, right, we should 8 rotated 90 degrees is the infinity sign. Well, now we can make some sort of direct physical proof that there are 7 ways to divide light because there are 7 colors, and that's reduction, right? In the universe we have expansion and contraction. That's expansion, we go from 1 vibration, expand it into 7 colors. Now contraction is how we go back from, range back to basis. But there's 7 colors or 7 ways to divide light, and 2 to the 3, that's some direct iteration of primary colors, right? We have, I don't even know what they are, red, blue, yellow, but there are 3 primary colors, and there are 7 colors in general. So, right, 2 to the 3rd is 8, there are 7 divisions of light. Somehow that is a direct, again, I don't know the final finishing touches on it, but that is a direct physical proof. First of all, the basis of 3, just walking through the things I have on the board. I have 1, 2 as brackets as an ordered pair because this is physics, and those can't represent anything, right? Lines don't exist, numbers don't exist, numbers are representations. And we've built enough mathematics to say we can derive logical relationships about the signs and just about the shapes. So 1 and 2 do not exist. And then so our basis for mathematics and as a physical consequence is 3 with including 3. And then 8 rotated 90 degrees, the infinity sign, with not including the infinity sign, and that produces our 7 divisions of light. So now we can ask the question, what is iteration to exponentiation? Right? Exponentiation is a very clear mathematical operation, 2 to the 3, n to the m. But how do we take primary colors and iterate them and produce the range of colors we have? In general, how do physical systems iterate rhythm, intention to have expectation? So exponentiation, originally, right, the universe is trying to figure out its dimensions. It expands really fast. That's why inflation cosmologically exists. I want to talk about inflation economically in my finance videos, but that's why the instability, the unknowingness of the geometry of the universe, of the instability, that's why exponentiation as a mathematical operator is relevant. But more generally, how do we iterate primary colors to produce any color we can see? Like I said, there's 7 base colors, but just like the different shades and whatnot. That iteration should give us some insight into more general physical questions. What this does is this gives us a numerical basis for our physical basis. So I wanted to talk about that. I also wanted to talk about just another random thought. about infinity, right? We've been talking about infinity in a very clear geometric sense, vertices and line segments, right? If our end polygons increase to infinity, the vertices and line segments, they go to a circle, but that's not to volume. Right? 3 is our basis. There's no, you're not increasing the dimension, right? When, again, just to detract infinite years back to string theory as is, when you say there's 14 dimensions or 30 dimensions, just stop saying that completely and entirely. But anytime we're talking about infinity, you're not talking about increasing the dimension of a system. You're talking about increasing the iteration of a basis. And that's just what I want to say there. Physically, now getting back to more mathematics or logic, let me start over. So that's a very, very clear physical argument. Again, the proof, the 2 to the 3, and then divide 1 7 times, or that's some sort of numeric physical mathematical proof. Beginning just more some general laws or general, talking about the preservation of dynamic, talking about the structure of words, syllability. We've introduced that through songs. How does syllables relate to logic, and how do you write a good song? Syllability, generality, and equivalent statements. Well, now we can make the statement, there's our physical basis. Now logically, any word with the same amount of syllables is equally general. Any word with less syllables is more specific, and any word with more syllables is more general. So when we're talking about, solving first principle linguistic axioms, I will show sensorality with an S directly, with the sound E to another word with the sound E that's already clearly defined. Just admission at Physicist Anonymous. I don't know what the fuck chirality is, really. I have to think about that every single time, and I think it has a good physical definition. Chirality and reflection. How do those relate? Again, how do they switch the direction? That is a clear physical response, and I don't know it. Just being honest. But syllables and natural numbers, those are the equivalent statements I just said. But remember, basis is the bottom, the most simplistic. Range is the most comprehensive, the most applicable. So if you solve like a range question, just specifically, if you solve the fundamental theorem of psychology and you directly derive that to physics, the completeness of the psychology solution will, like I said, imply, expand, provide insight to the physical explanation. And that's just because range is more applicable than basis. And that's what a mathematical proof is just trying to draw the most general relationships you can. But just consider the syllability and the physical implications of information versus inertia, right? Inertia is resistance. Well, in the last episode, and in general, that's clearly evident, where it said in is typically a negative prefix. So information, 4, inertia, 3. So information has to be more general than inertia. So how does information relate to inertia? And that would be our fundamental physical relationship, right? Physics just has to be correct. But again, physically, inertia is the resistance. Information is, give me another word, is what? Information is informative. Information is expectation. Information changes expectation. And so I just keep iterating that again, tons and tons of times a day. But that's an example of syllability. Now, for the equivalent syllability, energy, energy versus entropy. Right? Energy, the potential to move. Entropy, the not potential to move. Right? If you have a disordered system, you can't use that dissipation, that disorder, to move a system. So we can start again, drawing complete physical relationships in complete linguistical generality. Discreteness, completeness, syllables, words, and sentences. How do we apply discreteness and completeness to syllables? Are there complete sentences? Yes. Are words discrete? Maybe. Let me just give you try to prove something that I don't know if it's right or wrong. Let's say words don't exist. Words don't exist at all. Sequences of sounds exist. So what makes a word discrete? What makes you identify a word? Or we've talked about the preservation of dynamic. You'll speak different sounds in complete words. Or it's the rhythm. It's how you inflect the tone or the context you're talking in. But are syllables complete? Can we have complete syllables? What implications does that have to words? What is completeness to discreteness? Discreteness is complete. Complete is discrete. Playing around with logic, don't know what to do with that there. And now let's just talk about intelligence levels in the context of mathematical proofing and mathematical research. So now just more comments on intelligence levels, again for practical, real reasons. Let's consider a bunch of different people. A person that considers themselves a casual math guy, a PhD student or a PhD person, a top of the field lecturer, someone who society has deemed genius, Isaac Newton, Albert Einstein, a polymath, Leonardo da Vinci, and then a first principle scientist, which again is not on recorded history. So casual math guy, who's that? That's the person again that they self-classify as a math guy. Maybe they're on Quora commenting about intelligence, saying they did well in school, or the person that was a good math guy for the first 2-3 years of college but didn't get a PhD. Right, I think that intelligence level, I don't know, is 110 to 115 IQ points. And do I think IQ is valid? Again, at measuring something, sure. Inherent analytical ability, yes. I think people who deny that are just, again, in their own sad sack world. Because again, you don't have to be good at math to have a wonderfully amazing life. And pretty demonstrably, being really good at math is pretty net negative. And by pretty, I mean literally profound torture. Let's get there. All right, a PhD in math, I think there's certainly stats on this. I've read some of them, not recently. But I think like a casual math guy, 110 to 115 IQ. Your average probably medical doctor, 120 to 130. Your average PhD in mathematics, economics, philosophy, anything rigorous thinking, even though philosophy is not real. 130 to 150, 160. Top of the field, 170, 160, 155, 160 to 182 to 220. And then I would say the word genius genuinely requires creativity of application of research, right? 180 to 220, you can learn anything. And like I said, just a lot of the responses on Quora, they'll say the words, they can extend the logical implications. Cool. Where the fuck are your publications? And so when I'm saying, if you can go to a university and lecture about math, you got to have some IQ points because people might not think that's a very advantageous career path, but lecturing and being a teacher is a very respectable thing to do in general. But it requires raw intelligence. And so genius, like I said, I've talked about that, but that requires a real creativity component to it. It's like Albert Einstein, I don't know if it was officially tested, but I think it was 165-ish. But your IQ is really just like your toolbox, your capacity to do stuff. So now, right, your average casual math guy and your PhD is not going to compete with a genius. I think that for intelligence, your IQ test is standard deviations 10, 15 points. In general, I'm not sure how standard deviations are calculated, rigorously figured out in 5 seconds, but just as is. But polymath. What is meant by the word polymath? Polymath means you are the top of the line person, not debatable, not kind of, in many different fields, right? I really think this is where effort stops playing a role, is from genius to polymath. Genius strictly being profound, productive output, right? You don't need any IQ points to be a musical genius. Buckethead. I've never even listened to much of his songs, but and if you put out an album a week, like that's creative. That's again, there's some IQ points I really think is like bounded by scientific research, but the word genius just means creative output substantially past any other person in the field. Blah blah blah. Right? Like Albert Einstein was remembered for his creative genius. Genius, you can still have adjectives. Polymath is when you're just, there's no other fucking person kind of fucking close. Like, for example, Wayne Gretzky would be a polymath equivalent of hockey. And so polymath, I think historically and demonstrably, again, the IQ can go down to anywhere between 165 and 180. And it can go up to anywhere to about 600, I believe. 600 to 700. But I really want to talk about even a first, what is, I have a website called firstprinciplescientist.com. the jump from polymath to first principle scientist. Not, a polymath has some proofs. Not Euclid wasn't a polymath, but he was a genius at math. He had 4 axioms, people remember him as wild, really smart, 450 theorems. The jump from polymath to first principle scientist is I've mastered those things in infancy, in early childhood. Mathematical derivation, linguistical derivation, logical understanding, physical reality. A demonstrable physical framework that you've been operating in since early childhood to a point where it's indistinguishable to other people. That's really when you go from even I would say even like 800 to 900 or 900 to 1,000. I even like 900 to 1,000. Like I said, I can list theorems and it's not even like relevant to my proofing. I can prove things that's not relevant to my reductions. I cannot die and I will solve big science. So the thing that I want to like, first principle science. You've never met a polymath. A first principle scientist. The difference between PhD and polymath is profoundly indistinguishable. The difference between top of the field and even genius to first principle scientist is not. You're playing a different game, like for real as it can be. And though I'm still a person, like I said, IQ and EQ, my intelligence quotient. Like I said, when people interact with me, they notice that immediately. It gets even more. It's like the ways I can learn, the amount I can remember, the things I can prove immediately. It's just a fucking carnival, man. It's like a bunch of sheep surrounding a wolf with opposable thumbs. People might baw at you for a little bit, but like, I don't need my thumbs. I can still just rip your throat out with my teeth. I don't like to even use violent examples, but it's just such a different level. And my point is to the society, to the expectation of what people expect at school, or even from Isaac Newton or Albert Einstein, is like Wayne Gretzky to somebody who's never thought about hockey before. And then they tie their skates and skate around for 5 minutes, and now they're going to go skate down a frozen Niagara Falls and not die or something. I mean, it's just tremendously different. So I just wanted to talk about being a first principle scientist. I am one. And first principle scientist, the difference between polymath and first principle scientist. Right, a polymath proves something and goes on world tours every day. I mean, I iterate these statements, again, it is what it is, hundreds if not thousands of times a day. To develop functional proofs, not to say, look at me. People have talked to me my whole life, never once, like, I've never hid my intelligence. Have I been intuitively aware that I'm way past it? Yes. But do something. Get shit done. And once I get shit done, I just put my money. Because it's not like, you're not going to accidentally start making me derive stuff. You're not going to like, talk over my head. You can either be respectful of my life, and it's everyone benefits, everyone progresses forward, it's a wonderful thing. Or you can try to like teach me shit, scold me, make me be obedient, And then we're back to again, and I don't get it. Go talk to your dog, they don't get the sentences, they get the intonation. I don't get your logic. Like, I really, I get it, and it's like 4 fucking syllables, and that's all of humanity. So, I've literally been iterating fundamental logic since early childhood. And, right, Isaac Newton developed calculus. Calculus, the whole thing, is not correct fundamental ontology. So, even with these words, there's still one basis, there's still one world to deduce. But people say they're exhausted, I'm fucking exhausted. I'm well over 27 and a half years old, and I have been doing this stuff every single day. Thanks for watching From Rhythm to Algorithm, Part 31, Basis and Range.